All right, 9.3, hypothesis test for a population mean, but now we do not have the population standard deviation. We're going to have the sample standard deviation. It changes from Z to T. So instead of having a Z test statistic, we're going to have a T test statistic, and it's calculated the same way except that sample standard deviation, and our critical T value is going to come from our T distribution. So we're going to have to go back to degrees of freedom. Also, with our sample, it has to be a simple random sample, either larger than 30 or from a normal, approximately normal population. So again, our critical T value is going to come from our T distribution. So let's first practice using degrees of freedom and how to get the critical T value. No longer are we using this table. We have to go back to the T distribution or technology. So to get the critical T value, it's going to depend on the type of test you have, the level of significance, and the sample size. The degrees of freedom is one less than the sample size. For this, it's going to be 26. A two-tailed test. Not only do you have to split the level of significance between the two tails, you have a positive and negative critical T value. So what I'm going to do is I'm going to go degrees of freedom 26, and I need to match that to the area in the right tail, which is going to be 0.025 after I split that in half. So 0.025 down to 26. 2.056. So the critical T value is both positive and negative 2.056 for that example. Here, if I have a right-tailed test, first of all, my degrees of freedom is one less than the sample size, so it'll be 60. If I have a right-tailed test, everything's in one tail, so I do not need to divide my level of significance. It's going to be a positive critical T value, so I go 0.01, going down to 60, 2.390. So it'll always be positive for a right tail test, and everything's in one tail. The area's in one tail. Right here we have a two-tailed test again. So we need to take the level of significance and divide it between the two tails. And my critical T value is going to be both positive and negative. My degrees of freedom is one less than the sample size. So if I go read it from the right tail, because that's how my table reads, 0.05 degrees of freedom of 15. 1.753, both positive and negative. If we have a left tail test, Everything's in that one tail, so I do not split my level of significance. My degrees of freedom will be 10, but my critical T value will be negative because it's on the left side, so I'm going to put a negative on it. After I read it, 0.05 and 10, 1.812. Alright, so let's do a hypothesis test. A FICO credit score is used by banks and other lenders to determine whether someone's a good credit risk. Scores range from 300 to 850, with a score of 720 or more indicating that a person is very good, a very good credit risk. We want to determine if the FICO score is lower than the cutoff of 720. She finds a sample of 100 people. In that sample had a mean of a 703 score and a standard deviation of 92. So in a sample of 100 people, the mean was 703 with a standard deviation of 92. That makes it a sample standard deviation. Can we conclude that the score is less than 720 at a 0.05 level of significance? So the population mean is 720. So the null is the population mean equal to. Alternative hypothesis is going to be, hey, we're saying it's less. The population mean is less than 720. Left-tailed test. Our t-test statistic sample mean minus the population mean divided by sample standard deviation divided by the square root of the sample size. Get my numerator divided by the whole denominator in parentheses negative 1.848. I'm rounding to 3 decimal places because my critical T values are out to 3 decimal places. A left-tailed test is going to have a negative critical T value. So I'm using a 99 for degree of freedom and 05 for the area in the tail. But 99 is not on the table, so I have to go to one less. The number lower than 99 is 80, so it's 1.664. Is this lower than this? It is. So because our test stat ended up in the critical area, we reject them. They're wrong, we're right. We do have enough evidence to support our claim. that it is lower or less than.